Hey everyone, and welcome back. I love it when you send over stuff for us to look at, and this one really caught my eye. Meta's serverless platform, XFaaS. Apparently this thing handles like trillions of function calls every single day.
Yeah, it's a pretty impressive system for sure.
It's wild. So we're going to dive into all the cool stuff XFaaS is doing, like how they manage these crazy spikes in demand, how they're tackling that dreaded cold start problem that I know I've definitely run into as a user, and even how they make sure one little function going haywire doesn't bring down a whole system like dominoes.
You know what's really impressive, besides just the scale, is their efficiency? They're reporting a daily average CPU utilization of 66%. And that's within Meta's private cloud environment.
66%. So you're saying they figured out how to make those servers work almost nonstop? I'm hooked already.
Uh,
But before we get too deep into the weeds, can you just give us a quick breakdown of what function as a service even is? For folks who might be new to this whole thing.
Sure. Function as a service, or FaaS, is basically a way for developers to run their code without having to manage servers themselves. So they upload their code, and the platform takes care of everything else.
So it's like ordering takeout instead of cooking. You get the end result without all the hassle. That sounds pretty appealing to developers.
Absolutely, really simplifies the development process. But there's a flip side to that. On the provider side, that convenience comes with a pretty big challenge.
Yeah.
Cost. Imagine having a restaurant kitchen, fully staffed, all the equipment, but only a handful of customers show up at any given time.
Yeah.
That's essentially what many FaaS platforms face. Resources are just sitting there idle, waiting for demand to spike.
Okay, so that makes sense. So how does XFaaS manage to be so much more efficient? Is it some super secret, ultra complex algorithm?
Well, the paper does outline a pretty sophisticated architecture, but at its core, it's really all about smart resource management. Let's take a look at Figure 6 in the research you provided. This diagram gives us a high-level overview of how XFaaS is designed.
Okay, so what are we looking at here? It kind of looks like a flow chart with a bunch of different boxes.
Think of it like a well-coordinated factory. When a client, like a developer, wants to run a function, they submit a request. That request goes to a component called the submitter, which is kind of a gatekeeper. It batches similar requests together and sets limits on how many requests can come through per second to make sure the system doesn't get overwhelmed.
So it's like preventing a stampede of requests from clogging up the system. Makes sense. What happens next?
From there, the request goes to a queue load balancer, which decides which durable queue to send it to. You can imagine these queues as like waiting rooms where requests hang out until they can be processed.
Okay, so we've got the submitter organizing things and then the load balancer directing those requests to these waiting rooms.
Right. Now another component comes in, the scheduler. This is the foreman of our factory, constantly checking those queues, prioritizing requests based on importance and deadlines, and deciding which worker should handle each task.
So not all requests are treated equal, huh?
Exactly. Some functions are more time-sensitive than others, and the scheduler takes that into account. And speaking of workers, these are the actual servers that execute the code. The scheduler makes sure they're not overloaded, and that work is distributed effectively across multiple data centers, which adds another layer of complexity. XFaaS has to make sure everything's running smoothly across different physical locations.
Wow, just thinking about all those moving parts makes my head spin, but it's this intricate design that helps them reach that incredible efficiency, right? Speaking of efficiency, the paper talks about the cold start problem, something I've definitely experienced as a user. It's super frustrating when an app takes forever to load.
Oh, absolutely. Those delays can be a real pain. From a developer's perspective, a cold start happens when a function is executed for the very first time. The platform have to find the code, set up the execution environment, load necessary libraries. It all takes time.
Right, and that's all before the function can even start doing its job. So how does XFaaS deal with this?
They've got a multi-pronged approach. They start by preloading the code for common functions onto the worker's disks. This way, the system doesn't have to go searching for it every single time.
Oh, so it's like having the ingredients prepped in the kitchen.
Exactly. They also take advantage of the trust inherent in their private cloud environment, running multiple functions in one process, which really streamlines things. This is a bit different from public clouds where security and isolation between users is really important.
Interesting point. So being a private cloud actually gives them more flexibility in how they optimize for efficiency. And the paper mentions something called cooperative JIT compilation. What is that?
Okay, so think of it like a group of students studying for a test. Instead of each student having to figure out the material on their own, they share notes and insights, helping each other learn faster. Similarly, In XFaaS, workers actually share information about the most efficient way to execute code. One worker figures it out and then shares that knowledge with other workers, saving everyone time and effort.
That's really clever. But wouldn't all that shared information like overload the worker's memory? I mean, we're talking about a lot of functions here.
That's where locality groups come in. Imagine organizing your toolbox so that all the screwdrivers are in one drawer, the wrenches in another. So locality groups organize related functions and workers together to improve memory efficiency.
So XFaaS is basically a master organizer, keeping everything nice and tidy so nothing gets lost or slows things down. And it seems to be working. The paper shows that even under heavy load, workers only handle a small number of functions, and their memory usage stays pretty stable. Figures 9 and 10 really show that.
Yeah, it's all about reducing wasted effort and making the most of what you got.
Okay, so we've covered how they handle those cold starts and how they keep things organized with these locality groups. But we know that demand for these functions can be all over the place. The paper mentions a peak-to-trough ratio of 4.3, meaning demand can be over 4 times higher at its peak. How do they deal with that without everything just crashing?
That's where XFaaS really gets interesting. Instead of trying to handle every request immediately, they recognize that some tasks can actually be delayed without causing any problems.
So it's about being strategic and flexible, like a chef who preps ingredients ahead of time for the dinner rush.
Exactly. They use a system called quota management, which is like giving each function a spending allowance for resources per second. This prevents any single function from hogging all computing power and ensures a fairer distribution.
I like that budgeting analogy, but what about those functions that actually do need to be executed quickly?
They've got that covered too. XFaaS uses a combination of techniques, including time shifting, less urgent tasks to off-peak hours.
Like running the dishwasher overnight when electricity is cheaper.
Exactly. And then there's global dispatching, which basically spreads work across different regions based on available capacity. Like a restaurant with multiple kitchens. If one kitchen is slammed, they can send orders to a less busy kitchen to keep things moving.
That's brilliant. So they're constantly moving things around to avoid bottlenecks and keep everything flowing.
Yeah, and it's remarkably effective. If you look at figure 2 in the paper, you'll see they've actually managed to flatten out those demand spikes. It makes the whole operation much smoother.
It's like they've choreographed this perfect dance of efficiency. Okay, so they've figured out cold starts, they've got demand spikes under control. Is there anything else they have to worry about?
Well, one more crucial aspect is protecting what we call downstream services. XFaaS functions often interact with other systems, like databases. And if those downstream services get overloaded, it can cause a whole cascade of problems.
So it's not just about XFaaS running smoothly, it's about making sure it doesn't mess up other parts of the system. Kind of like a runner in a relay race who can't just drop the baton.
Perfect analogy. And to address this, they have this really smart mechanism called back pressure.
Back pressure. Does that have anything to do with those times when my internet slows to a crawl because everyone in my neighborhood is streaming movies?
You got it. Think of those downstream services like your internet provider. They have limited capacity. If too many functions start hitting a database with requests, the database can actually signal back to XFaaS saying, hey, I'm getting overloaded here.
And XFaaS taps the brakes.
Exactly. It slows down or pauses the functions that are contributing to the problem. This prevents one overloaded system from taking down others. Figures 13 and 14 show just how effective this can be, especially during outages or migrations.
That's incredible. It's like they've built in safeguards to protect the entire system.
And what's even more fascinating is that these techniques might have applications beyond Meta's massive scale.
You mean even us regular folks using public cloud services could benefit from this? Tell me more. This is where it gets really interesting for me.
Yeah, absolutely. One area where I think public clouds could really learn from XFaaS is global load balancing. Right now, most public cloud providers tend to keep functions within a single region. But imagine if they started distributing work across multiple regions based on where there's capacity, just like XFaaS.
So instead of each region being like its own little island, they could all work together as a global team.
Exactly. It's a much more holistic approach to efficiency. And this leads to another key takeaway from XFaaS. Shifting our focus from just speed to utilization and throughput.
Hold on, I always thought those were basically the same thing. Doesn't a faster system automatically mean it's being used more efficiently?
Well, not necessarily. Think of it this way. If you're obsessed with making things faster, you might end up buying a super powerful sports car just to drive to the grocery store once a week. Sure, it's fast. But is it really an efficient use of resources?
Okay, yeah, I see your point. It's like having this huge kitchen that's only used for making toast. You might be making toast really quickly, but you're not exactly maximizing the use of that kitchen.
Precisely. XFaaS demonstrates that you can achieve incredibly high utilization, meaning those servers are actually working most of the time, without having to sacrifice performance. They're challenging that assumption that we have to choose between speed and efficiency.
So how do we get public cloud providers to start thinking this way?
Well, pricing could be a powerful incentive. Right now, a lot of public cloud pricing models are based on usage time, which can encourage users to optimize for speed, even if it means higher costs in the long run. But what if there were pricing tiers that rewarded users for being flexible with their execution times?
So like a discount for running those less urgent tasks overnight when demand is lower, like that time shifting idea we were talking about earlier.
Exactly. It could be a win-win. Providers reduce their infrastructure costs and users save money.
Now that's something I can get behind. But what about those big companies that are already using the public cloud, the ones running these huge applications and using tons of resources? Could they implement some of these XFaaS techniques themselves, even if the cloud providers aren't offering them yet?
It's definitely possible. The paper actually highlights that a small number of very large teams within Meta are responsible for a huge chunk of XFaaS's capacity, which suggests that large customers on public clouds could potentially build their own systems that mimic some of those efficiency optimizations.
So even if the public cloud platforms don't fully embrace these ideas right away, there's still a way for the big players to benefit. That's pretty encouraging.
It really shows how innovation can happen even within these massive systems.
Mm.
And who knows, maybe these techniques will eventually become more mainstream as the benefits become clearer and the technology evolves. This whole idea of shifting our focus from speed to utilization really makes me wonder, what would a world optimized for utilization instead of speed actually look like?
That's a big question, almost philosophical, isn't it?
It is. I think it would be a world where we're much more mindful of the resources we use, not just in the digital world, but in the physical world too.
So instead of always wanting everything instantly, we'd be okay with waiting a little bit if it meant using less energy and being more efficient overall.
Exactly. We'd be more deliberate about how and when we use computing power. We'd be more willing to embrace flexibility in our applications, understanding that not everything needs to happen right this second.
It's like choosing to walk or bike to the store instead of automatically hopping in the car. Sometimes a little patience can go a long way.
I love that analogy, and I think that shift in mindset could have a huge impact, not just on the cost of cloud computing, but on the sustainability of our whole digital world. If we can reduce the energy we're wasting on idle resources, that's a massive win for everyone.
That's a really powerful thought, and it kind of reminds me of that cooperative JIT compilation concept, where those worker servers are learning from each other and sharing knowledge to become more efficient. What if we, as humans, did that more? Could we find ways to collaborate and share resources more effectively, to reduce waste and improve our well-being?
That's a fantastic question. It makes you think about the potential of collective intelligence, not just for machines, but for humanity as a whole. Maybe there's a deeper lesson here about the power of cooperation and sharing.
It's definitely something to think about. Well, we've covered a lot of ground today. We've explored how XFaaS is designed, its efficiency, and even its potential impact on the future of cloud computing and beyond.
We've seen how they've tackled the challenges of cold starts and demand spikes,
Yeah.
and how they've made sure their system works well with others. Through that back pressure mechanism, it's a remarkable system.
And it's sparked some really interesting conversations about utilization, innovation in the public cloud, and even the implications for sustainability and collaboration in our digital world.
As we wrap up our deep dive into XFaaS, we want to leave you with this thought. What other applications could benefit from these approaches?
How could you apply these concepts in your own work or life?
It's a question worth exploring. Maybe the answers are closer than we think.
It's funny, when we started looking at this research paper on XFaaS, I didn't expect to go down so many rabbit holes. But we've gone from these super technical details of a serverless platform to big picture questions about the future of cloud computing and even the role of collaboration in the digital world.
It's true. I think it just shows how everything is connected. Exploring one system can lead to all these unexpected insights.
For sure. So as we wrap up, what are some of the key things you hope listeners will take away from our deep dive into XFaaS?
Well, I hope they've come away with a better understanding of how crucial good system design is. Not just for making things run smoothly, but for building a more sustainable digital world.
Yeah, that's such a good point. XFaaS shows that we don't have to choose between performance and responsibility. We really can have both.
Absolutely. And I also hope our conversation inspires listeners to think about how they can apply these ideas. Things like efficiency, collaboration, resource management in their own lives and work.
Yeah, maybe they'll find ways to cut down on waste in their own processes, or even advocate for more sustainable practices at their companies.
That would be amazing. Even small changes can make a big difference.
This whole deep dive has been a real eye-opener for me. I think it's made me realize how much more there is to learn about how technology actually works and how we can use it more thoughtfully.
I feel the same way. And the coolest part is that there's always something new to discover.
Well said. So, to everyone listening, we encourage you to keep that curiosity alive. Keep asking questions, keep exploring, and keep pushing the boundaries of what's possible in tech.
Who knows? Maybe one of you will design the next groundbreaking system that changes the world.
That's a great way to end things. Thanks for joining me for this deep dive into XFaaS. Until next time, keep learning, keep innovating, and keep diving deep into the world of tech and beyond.